Welcome back to my channel. For this session, you have discussion about conversion of NFA into DFA. Let's consider a sample transition table. NFA transition table. Let's write the 5-tuple notation first. Q is equal to Q0, Q1, Q2. Sigma is equal to 0, 1. S is equal to Q0. F is equal to Q2. The same 5-tuple notations we are using here. The same Q, but Q is going to be Q dash and delta is going to be delta dash and F dash, because states will be varied. We are going to convert the multiple states into a single state. Let's see the constraints. We have some constraints to convert NFA into DFA. The first constraint is determining number of states, and second delta dash transition, which is derived from. To determine number of state, we have a formula Q dash equal to 2 to the power of n, where n is the number of states. Here n is equal to 3, so 2 to the power of 3 is equal to 8 states. So start from pi, all possible states we have to write. So it will be like Q is equal to pi Q0, Q1, Q2, Q0, Q1, Q0, Q2, Q1, Q2, Q1, Q2, Q3, all possible states. And now we can write the delta dash. And before that, you must know this rule: delta dash of Q0, Q1 is equal to delta of Q0, Q1 in curly bracket. So you can write the Q0, Q1 in curly bracket equal to Q0, Q1 in square bracket. This is must for these diagrams. Now we are going to take transition against every state with input 0, 1. Now the first state is Q0. So again 0 we have to take delta dash. Delta dash Q0, 0 is equal to Q0, Q1. From the transition table you can write, and this is derived from the transition table, and further this curly bracket can be converted into square bracket, which is suitable for DFA transition table. In the next step, we have to take transition against input 1. So according to the given transition table, it must be Q2. Next, we have two resultant values. First, we have to take the delta transition for this state, then afterwards Q2. Now Q0, Q1, 0 is equal to Q0, 0 and Q1, 0. We can split and write. And before that, you must use the squarely curly bracket. Then only you can refer the transition table, because the complete transition table belongs to delta, not delta dash. Now refer the value for Q0, 0, which is Q0, Q1, and Q1, 0 is Q0. Now combine the result. You have Q0, Q1 in curly bracket. That is possible to write Q0, Q1 in square bracket. Now take delta dash for Q0, Q1 against 1. The same this Q0, Q1. We are still standing this Q0, Q1. We have checked only against 0. Now 1. So delta of Q0, Q1, 1. So now refer the transition table, which is delta of Q0, 1 union delta of Q1, 1. Now refer the transition table. Q0, 1 is Q2. Then Q1, 1 is Q1. Now combine the result. You have Q1, Q2. Then these are in curly bracket. That curly bracket in Q1, Q2 must be written in Q1, Q2 in square bracket, because in DFA we will use only square bracket. We are converting the multiple states into a single state. We have completed for Q0, Q1 against input 0, 1. Let's come to Q2 and we have to find delta dash for Q2 against 0, 1. So Q2, 0, refer the transition table which is pi. No such transition, so pi. Q2, 1 which is Q0, Q1. These are already processed. So Q0, Q1 is already processed. You can leave this state. This is not a new state. Now we left with Q1, Q2. Let's see the delta dash for Q1, Q2 0. Delta dash for Q1, Q2, 1. First Q1, Q2, 0, which can be written as delta of Q1, 0 and Q2, 0. Now refer the transition table and write. Now if you get the value Q0 and pi, so finally you end with Q0. So already Q0 processed. Next we'll process for Q1, Q2 and against 1. So against 1, so delta dash of Q1, Q2 can be written as delta of Q1, Q2 in curly brackets, and let's write Q1, 1 union Q2, 1. Refer the transition table and write the values. So you will get the same result value what we have received in the previous steps. So now we have processed all the possible states, all the 8 states, all the possible states. Now we are ready to build the transition table and DFA diagram. First transition table. You can write the transition table like this. So all the possible states in the rows, columns and the inputs in the rows 0 and 1. So again 0, 1, 1 we can write the resultant values obtained in delta dash. Now the DFA diagram. So each state will be considered as two different states will be considered as a single state and the transition will be drawn. This is called DFA